According to Verizon's 2022 Data Breach Investigations report, over 80% of web application breaches involve stolen credentials. Today, credentials continue to be the leading organizational security weakness, yet most companies still manage their database passwords manually or let them sit unchanged for years. In this video, I'll show you how to automate database password rotation in AWS with just a few lines of code. A security best practice that could save your company from becoming the next data breach headline. Let me walk you through exactly how to set up automated secrets rotation for your Aurora Postgres database using the CDK and Lambda. Hi, if you're new around here, my name is Ryan. I'm an AWS certified solutions architect and developer, and my goal is to teach you modern serverless system design using AWS. Let's jump in. All right, so let's talk a little bit about the architecture and what we're going to build today. Automated secrets rotation, especially for database credentials, is an important part of any security infrastructure since manual password rotation is error-prone and often neglected. Today with our CDK stack, we're going to create a VPC, an RDS Aurora PostgreSQL database that sits within that VPC, database credentials for that database that will sit inside a Secrets Manager object, and a Lambda function that will also sit inside of our VPC that will allow it to easily connect to the database. Since this video is mostly about rotating the secrets for the database, I'm not going to go into a lot of detail on the database itself. If you're interested in that, you can check out another video that I did on creating an Aurora Postgres database. This video is going to focus more on creating the custom Lambda function and the logic associated with it that will rotate the database credentials in Secrets Manager. Our rotation Lambda function follows a 4-step rotation process where it will create the secret, set the secret, test the secret, and then finish the secret. And all 4 of these stages must pass successfully for our secret to fully rotate. Each event that triggers the function will contain a token to help ensure idempotency for our rotation. If any step in the process fails, the secret will not rotate and will stay whatever it was before. All right, so let's jump into the code and see exactly how this is going to work. So one thing that you're going to need for this Lambda to work is you're going to need a layers folder that has a package.json and a node modules folder that contains our PG dependency. This is the only dependency the Lambda function is going to need because the PG package will allow it to connect to the Postgres database and actually update our password. So jumping into the Lambda function here, of course, like we mentioned before, every secret rotation event contains a total of 4 different stages, and all of those stages have to pass for the secret to fully rotate. So in our Lambda function handler, we just have a switch case that is checking to see which step we are on for that particular function call. From the getSecretJSON function, we're just going to fetch our secret from Secrets Manager. For our generateSecurePassword function, we're just going to take in a single argument that's going to determine the length that we want our password to be. So using the JavaScript crypto library, we're going to generate a cryptographically secure password. We're going to first determine which characters we actually want to use in that password, and we just have those denoted by these 4 strings here. So we split up the characters that we want to get into 4 different strings because we want to ensure that we're getting at least 1 from each string in every single password that we generate. So that's why we're getting an upper, a lower, a digit, and a symbol for the first 4 characters of every password that we generate. Next, we're going to fill in the remaining length of that password with a bunch of random characters from any of the different subsets. Finally, once we have all of our characters and our password length, we're going to perform what's called a Fisher-Yates shuffle that's going to randomly scramble the password for us. The first action we'll take in our first step of create secret is fetch the existing Secrets Manager object. Then we're going to generate our secure password and we're going to set our new secret object as pending in Secrets Manager. In our second step, we're going to fetch both our pending and our current secret. We'll log both of those so we can see that they're different, and then we will initiate a connection to the database using our existing password. Once we are logged into the database, we will then set our new password. One thing to note here, and this is something that I was actually curious about, but if you log into Postgres using a password and then you update that existing user's password while you are logged in, it will not end your session and will honor that session until the session is actually closed. So you don't actually have to worry about losing the connection as soon as you update your password. Then we will go ahead and we will end our connection to the database. Then in our third step of test secret, we're going to get our pending secret from Secrets Manager. And then we'll connect to the database using our new password just to ensure that it works. Additionally, once we're connected, we'll just run a simple query to ensure that we can actually do things in the database. Once that finishes, we will end the database connection. In the final step of our secret rotation function, finish secret, we're just going to take that pending value in Secrets Manager and promote it to be our current value. And that basically finishes what our rotation function is doing. Let's go ahead and jump into the CDK stack so we can see how that's going to look. All right, so inside the stack here, the first thing that we did is we just created a security group for our Lambda function and put it inside of our VPC. Then we just took our DB security group and we made sure that we added an ingress rule to allow that Lambda security group to communicate on port 5432. Then, of course, we have our credentials being created here in Secrets Manager, and we have it being named as our PostgreSDB credential secret. And of course, we created our database cluster. We created our layer here that has our Postgres package. And then here in the rotation Lambda, we made sure that we put it inside of the VPC. We included the layer that has Postgres. We assigned it to the Lambda security group, and we passed in the cluster secret ARN so that it can read it from Secrets Manager. And of course, we granted the Lambda function to have read and write capabilities on that secret. Finally, on the secret, we added a rotation schedule. This rotation schedule takes in our rotation Lambda, and it takes our automatically after duration to 4 hours. 4 hours is the lowest amount of time that you can set here. However, as we'll see in a second, we can actually trigger this at will inside of the AWS console. You probably don't need to set this to 4 hours. I would imagine rotating the database credentials probably once a week or once a month is probably fine. And we also have it set to immediately rotate the secret anytime we update this AWS stack. So I went ahead and deployed this already, but the one thing that you are going to have to do before you deploy it is make sure that you build your Lambda function and compile it to JavaScript. As you can see here, our code from our Lambda function is inside of the dist folder, not just our raw TypeScript file. All right, so let's go ahead and jump into the AWS console and I'll show you what this looks like. All right, so jumping here into the console, we'll go over to our CloudFormation stack. We'll jump into our resources here, and under our Aurora cluster, we will find our secret. We'll go take a look at that here. We can hit retrieve secret value, and here in our secret values, we can see all of the different key value pairs that are created when we use the from secret on the credential object in the CDK. And we can note here that we've got our password, which starts with Y2R. Now, if we go over here to the rotation tab, we can see that we've got rotation enabled, and we can see our rotation schedule of every 4 hours, but we can click this button here, rotate secret immediately, and we can see what happens. We'll click that, we'll hit rotate, then we'll jump over here to the actual Lambda function. If we go to monitor, we can click on CloudWatch logs here, which I already have open. We'll go ahead and refresh the log stream, and we can see that we have a new entry here. We'll open that, and we can see all of our console logs that we were sending in our Lambda function. So we can see we've got our new secret, and we can see that it's got a different password here that starts with IIE, and we can open these as well, and we can see our current secret with the Y2R, and we can see our new password and the new secret with the IEE here. Then we can see that we successfully connected to the database in our set secret function. Then in our test secret function, we can see that we successfully logged into the database and we were able to successfully run our test query. We close the connection, and then we can see we promoted our pending version of our secret to our current version of our secret in our final step. So we can actually go verify that in Secrets Manager. If we go to overview, we can retrieve our secret value again, and we can see that our password is indeed the new one that starts with IEE. So enabling Secrets Manager rotation is actually an AWS best practice, and it greatly increases the security of your applications. Again, 4 hours is the lowest amount of time that you can set, but you want to make sure that you set a value that makes sense. One modification that you could make to this architecture would be to add some form of notification, just to let you know that the secret was successfully updated or to notify you in the case that there was an error. That about wraps up the video today. If there's any other videos that you'd like to see me make on this channel, then please let me know down in the comments. And I also just wanted to thank you for watching this video. All of the support and all of the videos that you have watched up to this point have actually enabled me to join the AWS Community Builders program, which has been a long-term goal of mine. So thank you so much. I'll see you guys in the next video.